Okay, today we're going to write the equations for the lines using y equals mx plus b form. Real fast, I'm just going to do a couple examples of review here. So in this review, I'm supposed to identify the slope and the y-intercept, and I can do that using slope-intercept form just like we did the other day. So the m is 2/3 and the b is 7. On this problem, my m is negative 1/5 and my b is 12. And on this last example, my m is actually 1 and my b is 3. I'll go ahead and write that one. M is 1, b is 3. Moving on to some other examples here. When we're writing an equation in slope-intercept form, our final answer is going to be y equals mx plus b. So these are very simple problems because they give me the m and the b. So I'll have y equals my m, x plus b. All I have to do is substitute in 4 and 6 for my final answer, 4x plus 6. So it's very easy to write an equation for a line if you're given the slope and the y-intercept. We'll just fly through these examples very quickly. So y equals mx plus b. I'm going to plug in the 1/2 and the negative 3. So I can write my answer as 1/2 x plus negative 3, or I can simply write minus 3. My next example, we have y equals mx plus b. I only need to substitute in my 3/4. There's no reason to add in the x. Plus 0 doesn't do anything to the problem. For this next one, y equals mx plus b. If I plug 0 in for m, I no longer have an x. So really all I need to do is write down my negative 9. So y equals negative 9 is that solution. And then this last one I'll do would just be simply y equals 0 because I'm plugging in 0 for x and for b. The second type of problem that we'll be given today is given a slope and a point. We are going to use slope-intercept form today, so we're going to substitute values in for the x and the y. This m is going in for the m, so the slope is going in for the slope. The x value will be 2 and the y value will be 1 because every ordered pair is labeled x comma y. So we're going to make these substitutions. My y is 1, my slope is 1, my x value is 2, and those are multiplied together plus b. This allows me to find b, so I'll do that by solving a basic equation, subtracting 2 on both sides, and getting my b value is negative 1. My final answer then, of course, is supposed to be in that y equals mx plus b form. I need to fill in my b value and my m value. My m is 1, and my b I just found. My b value is negative 1. So I could simplify this problem just by saying it's x minus 1, because you don't have to include the 1 in front of there, and you can make your plus negative actually a minus sign. Let's look at a second example of this. So y equals mx plus b. I plug in negative 5/2 for my m. My x value is over here. It's 2, so I'll plug 2 in for my x. And my y value is 3, so I'll plug 3 in for y. I do have to solve this part first. I need to multiply that first. So I'm going to do that off to the side. Negative 5/2 times 2 over 1. Those cross reduce and give me negative 5 plus b equals 3. Add 5 to both sides, and I get 8. My final answer then will be y equals some m x plus whatever my b value was. So my m is 5/2, and my b value is 8. So I'm substituting the b in and the m for my final solution. Here's another example of this. So we have y equals mx plus b. I'm going to plug in negative 2 for my m. My x value is 3. And I don't know my b, but I know y is 0. So I'll plug 0 in here. When I solve for this, I get 0 equals. This is negative 6 plus b. That allows me to solve for b by adding 6 to both sides and I get b is 6. Final solution, y equals m is negative 2, x plus my b value is 6. Equations of lines typically have both x and y in them. Let's look at one more example here. One with a fraction, so I've got y equals mx plus b. Plug in my m value is negative 2/5. My x value is 3. And my y value is 7. So I end up getting negative 2/5 times 3 over 1. These do not cross reduce, so I have to multiply it straight across, which gives me negative 6/5. You can also call this negative 1 and 1/5. I will go ahead and use negative 1 and 1/5 here because it will be easier to solve the equation. I can add 1 and 1/5 to both sides, and that gives me 8 and 1/5. So my y-intercept happens to be a fraction answer as well. So my slope was negative 2/5, and my b value was 8 and 1/5. Again, all we're doing is substituting values in for m and b. If we're given m and b, it's simply just plugging them in. If we're not given m and b, we have to solve for b and then substitute them back in.